Today is going to be a pretty special episode of Roid Rage. We're going to talk about reliability. I'm not going to define it yet because I have someone in the room who can give a way better definition than I can.
Wait, it's special because Robin's not here, right?
I mean, it is special. I mean, it's unfortunate you don't get to dox anybody, and we avoid probably 95% of the dad jokes, although, I don't know, maybe we've got dad jokes over here. But without further ado, we have Hans Köenigsmann. Did I pronounce that correctly?
Pretty much, yeah.
Okay, pretty much. Means I got it wrong, but I will get better. He is, for those of you who don't know, he's a former VP of Build and Flight Reliability at SpaceX. He was there basically from the beginning and saw all the good, the bad, and the ugly. And he's here to talk about reliability with us. So, Hans, can you introduce yourself to our listeners?
Sure, yeah.
Who are you and why are you here to
Why
talk
am I
about
here? Yeah, I mean, Hans Köenigsmann, so I went to school in Germany to college there too. I had my first 2 jobs basically there.
Okay.
Built satellites actually, a small satellite at the University of Bremen. And learned basically I was interested always in attitude control and satellites and so on. And then I got picked up by a company here in LA. They basically imported me and did this whole immigration thing that now everybody talks about. And then I worked 7 years there working on different spacecraft, but also on small rockets.
Okay.
Like
What company was this?
It was Microcosm.
Okay.
Worked on suborbital rockets, basically. Kind of got me interested in rocketry a little bit.
Okay.
And then Elon Musk basically picked me up, more or less by accident. I just met him, and he was in the process of founding SpaceX. Tom Mueller and Chris Thompson were already on board, and so they just asked me if I could join, primarily as an avionics person.
Okay.
So it covered more than electronics, but it's electronics, it was guidance and control, it was software, it was flight safety. Did I miss anything? It was like the whole thing that neither Chris Thompson on the structures covered and Tom Mueller on the propulsion covered.
So you were just the
ended
rest.
basically on my side.
Where did you meet him at?
I met him at a rocket competition, like a weekend up in Mojave. And I actually went there with Quinn Shotwell, because I used to work with her before SpaceX.
Okay.
Wait, so Gwen was at Microcosm?
Yeah.
Oh, really?
At the time, yeah. And so we drove up there, spent the weekend there. Elon was there too, probably looking around, probably scouting for talent and just in general trying to figure out how this whole rocket thing works.
Yep.
So, and that's the rest is history a little bit.
So what years were you at SpaceX?
I started in 2002.
Okay.
SpaceX itself I think it was formally founded on Pi Day 314 in 2002.
Okay.
And then I joined in May, 28th of May.
Okay.
Basically right after Thompson and Mueller, basically the third or fourth, depending on your current technical employee. Yeah. And then we started basically hiring people like crazy.
Yeah.
Yeah.
And when did you leave?
I left 21.
Okay. Got
So
it.
19 and a half years.
Yeah.
Yeah.
Wow, so you were there almost 20 years.
Yeah, almost. Yeah.
Wow.
That's true. So I saw a lot of change.
Just a little bit, right?
It grew a little bit over those time. We had a couple launches. I think actually since I left, there's going to be like way more launches than until I stayed there, because the rate got so much higher. But on the first launches, it took us like half a year to get the rocket off the ground. Yeah. So it's like, and now I look at them and it takes like a half day.
It's crazy, the speed.
Yeah.
What did you think about when you were first approached by Elon to potentially join the company?
I actually thought, this is great. So for a couple of reasons, I think somebody gave me his name before I did some research, and I knew that he wanted to spend some serious money on space exploration and Mars. Yeah. So I thought, to me as an engineer, somebody putting the money on the table and saying, "Go ahead and build it," it's just like perfect, because then you don't have to deal with like trying to find the money and going from one little study to the next little study and so on and so forth. Because that was the mode I was in before. Like I was either working for other companies, consulting basically, or we had like little studies under SBRs and other vehicles that basically just paid for my salary. Yeah. And so this was basically a purpose-driven thing, which I really thought was awesome. And then there was also a blank sheet of paper. Because Elon basically had no history in aerospace in that sense. He wanted to have the best solution that we can come up with. And that meant you could actually try to build a really clean vehicle from the get-go.
Yep.
Yeah. What did you guys think? So on that note, when you built a vehicle from the ground up, right, from a blank sheet of paper, what were the things on avionics you changed over the way?
We changed a lot. I mean, the one constraint we had was time at the end of the day. Time and to some extent also money, right? It sounded like a big number when we started, but we knew it's gonna go away, and we got to spend it. And then Elon said he's in for 3 launches or 3 failures basically. We needed all 3 of them, and he was still in. Money and time were the 2 constraints, and so time being the constraint, we started to build everything at the same time in parallel, right? Okay. And so we made compromises on both like computer, battery, and so on and so forth. And so we looked at it later and go, well, yeah, it worked, but it wasn't a great solution, So we got like, it's a PC-104 system. I don't think it still exists. Maybe it does. It's like, I called it the ATM, or like, because it can't do a lot, right? But it was actually totally sufficient to fly a rocket. We had to make some changes because there's so many valves you have to flip on the rocket, and so you have to add stuff basically to the ones you can buy, and then we try to basically package it so that it survives the launch. Which is
Was Falcon 1 single string?
Yes, very much so.
Okay.
We had no luxury on dual string or redundancy and everything. We basically worked everything so that it should work during flight. Wow. It was all hand worked and hand soldered and everything because we had no time to set anything up.
Yeah.
Right.
Any like critical mistakes you made? Obviously, Falcon 1 first 3 launches failed.
Yeah.
Were any of those your fault?
The second one, I think, was mine. The first one, that we argued over that, but the second one was basically spun out of control because of sloshing baffles missing on the second stage, and that was under me, and I kind of presented that we had unstable solutions, but we also had stable solutions. So we had like analysis that was inconsistent, and one thing I learned is I had like 3 different models that were stable, and then we had 2 models that were unstable, something like that. And so we looked at that, and then Elon decided that we should fly it anyways. And my lesson out of that is that physics is actually not democratic. It's just doesn't matter how many models are in favor and how many ones are not in favor. It's if the model is right or wrong, right? I mean, that's what counts basically. And obviously models are never completely right. So I mean, this vehicle went pretty far. The first stage worked actually beautifully on that flight. The second stage spun out of control and got a couple thousand kilometers downrange. So it was pretty good compared to the first one. The first one was miserable. The first one was going up for 28 seconds, and then that shut down because we had a little fuel leak, and the fuel leak basically ignited at liftoff and then burned through some pneumatic lines that shut everything down.
So it shut down because of like propellant utilization, saying the tanks are dry?
No. So basically, the fuel leak was on a transducer, and just dripped down on the engine, and it just ignited and burned through the pneumatic lines for the main valves and stuff like that. So basically, what I always say is fire on the wrong spot. It's just not. It should be all the way down there, and it's like up there, and that's not great. But it was a combination, I would say, out of we concluded in the end that there was a B nut. I never actually know what happened to the A nut, but the B nuts are basically something that connect lines, tubes, and this was aluminum, and it had corrosion, probably, and so the stress corrosion case was what was concluded. I don't know. I mean, it's kind of like hard to tell because we never found the piece, but we left the rocket outside. It was in salt spray, and this particular B-nut was torqued a couple times back and forth. And part of that was also that we had to make changes on the engine controller. So I do have there's a factor of me going in that, but the B-nut is not my B-nut in that sense. Yeah. Yeah, it was partly, in my eyes, it was also careless because we left it outside and it corroded. We never did that after that.
How long was it outside for?
I think it was a couple of weeks outside.
Wow, so it's quite a while.
Yeah, we left it outside we left the island for a couple of days, came back and was left outside. We would never do that again, frankly. We learned how really harsh corrosion is there.
Yeah.
This was in Kwajalein?
That was Kwajalein, yeah. I mean, people would tell us where to park the bicycle. Yeah, if you park the bicycle upwind on the house, it would corrode basically by the time you got back. And if you leave it on the other side, it would survive another 6 weeks.
So it's just super dense salt fog,
like salt fog everywhere. Yeah.
Jeez, that's
exactly.
Crazy. How hard was it to build an avionics system? Today we have commercial space. We kind of understand it. You guys led the way, and we can go look at how other rockets were built. Like, how hard was it back then when you had, everything in rocketry was pretty classified. It was pretty under wraps.
So we didn't really look for we went out for vendors first and tried to get like components. And if you build this together, it's millions. And we just decided that's not the way what we want to do.
Yep.
So just to make it a little bit harder, we built everything ourselves. Although actually, in hindsight, this is hard in the beginning, but I think it's the only good approach. Yeah, because most vendors are aligned with like expensive rockets.
Yep.
And if you're trying to make it cheap, I mean, if I go all the way back, what SpaceX always tried to solve is actually not the physical problem, but the monetary problem, the financial problem with spaceflight.
Yeah.
Yeah. What held spaceflight down over decades is the cost.
Yeah.
Yeah, and not anything else. I mean, the physics we know, but we produced it at such a high cost that we could just not do it at scale.
Yeah.
Yeah. And so in that sense, that was the overarching mantra what we tried to do, and producing cheap meant in many cases do it differently than buying at an expensive outside vendor.
How much cheaper was Falcon 1 compared to, obviously different class rockets, right? But compared to something like a Delta IV? What was the cost of Falcon 1, I guess? What were you guys aiming for?
It's a really good question. I don't think I can answer this easily. So the price we listed was $6 million at the time. And the cost of the first one probably was more. Yeah. But in the end, if you would have repeated it, we would have probably been in like 5-6 million range on the rocket, something like that.
And that was how much mass to orbit for Falcon 1?
It was not as much as we wished. Oh man, that's been a while. I thought actually the target was like 1,000 pounds or so.
Okay.
Yeah, and I think we struggled with 500-600 probably in the end.
Yeah.
Yeah, but this is not unusual. Yeah, yeah. You have like a spec. You're building the rocket to the spec, and then you find out everybody gets overweight during their lifetime,
yeah.
and then the propulsion is like the ISP is not as good as it's supposed to be. So you obviously fall off on your performance, and then what you do is you iterate and design it better, and then you kind of like claw your way up to the original performance or even higher. Yeah?
Yep.
That's kind of what Falcon 9 basically did over many, many years.
Yeah.
So I'm pretty sure if he would have continued Falcon 1, he would have probably clawed back some of the performance over the long time. Yeah.
But still, $6 million at that point in history compared to $450 for Delta IV was a big price cut.
True, but I mean, Delta IV also could launch Falcon 1. Sort of.
Fair enough. Was there a small launch vehicle class that was operational at the time?
There was Pegasus. And
that was $55 million a launch.
It's true, but Pegasus on the other side was Pegasus really the first true commercial one? I think yes. But Pegasus was solid propellant.
Yeah.
And it's really hard to change the cost on that.
It also dropped off the underbelly of what was it? LC 1011, whatever. The Trijet.
L10 11, I think. There were two, right? There was the DC-10, there was a Lockheed and a Douglas, and I think the orbital one was the Lockheed one.
Okay.
The one that
I
had
think
the
you're
S-turn and the
and it had the
engine.
3 engines, right? It had
3
the
engines.
engine.
Yeah. Both have 3 engines. That's why the DC-10 has, I think, the straight line, straight engine in the tail, and the Lockheed one has the one with the S-turn, right? Neither one. I mean, people like to fly them, but they weren't really successful because they did have a reliability problem. Some of them, but like doors falling off and hydraulic lines being cut and everything. There were a couple horrific accidents.
And also, we just got so much better at jet engines that 2 jets were more efficient. That was a regulatory change in the 80s that just killed the tri-jets. That's why, because you could go to 2 jets for more than, 120 miles aircraft range.
It's the intercontinental operation basically with two twin engines.
Yeah, that's probably why they used them, because they became real cheap to operate to fly rockets off of.
True. I mean, what airplanes learned is something that rockets should probably mimic to some extent, or satellites in that sense. And that was basically, they had so many flights and so many data on what fails and doesn't fail, that they can basically improve very, very targetedly. Yeah. I mean, improve certain specific things like whatever jet engines, they know the maintenance intervals. They don't know that very well, and so they can also drive the cost down without risking lives and accidents, basically.
Right. Was there anybody else? I don't know how much the Russians charged at that time for a rocket launch. Like, were you guys alone on an island as far as class of rocket at that point in time, other than Pegasus?
Oh, yeah, I think so. The Russians were. Earlier than that, you could buy cheap Russian rockets, right? And this was basically the imbalance between salary in Russia versus salary in the rest of the world. So it took advantage of that to some extent. But then also the Russians learned that they can just sell the rocket for $1 less and you would still buy it, right? Yeah. Because it is $1 less and not necessarily $10 million less, So they learned how to do that. That's actually what I think motivated Elon to found SpaceX, because he tried to buy a rocket from the Russians, and the Russians basically just fooled around and tried to jack the price up as much as possible. And so building a rocket and developing this was the logical conclusion in that case. But there were other rockets too. Let's see. There was Orbital actually built Taurus at a later time. So there was that rocket. There was also a Minotaur, which is actually literally was half Minutemen and half, I think, Taurus.
Oh, is that what it was?
Yeah, that's fine. I think that's what it was, yeah.
Well, then was PSLV operational when you guys started?
The Indian one?
The Indian one, yeah.
They had some early versions of that, but I don't think they were very successful on the commercial market. The most successful on the commercial market was actually always Ariane.
Oh, yeah.
So Ariane was the European project, basically, and it took 4 iterations to get to something that actually would fly to orbit. I think they jumped even over certain. So I mean, this is how you actually not build rockets, right? You build the upper stage in Germany, you build the first stage in France, and then you build pieces in Italy, and then you try to actually get through the interfaces in all different languages, right? I mean, that's just like a logistical nightmare. But the goal in Ariane was always to bring Europe together and not necessarily to build the cheapest rocket. Yeah. But Ariane 4 was actually a good rocket. It flew commercially a lot of geostationary satellites. Okay. It was actually also almost optimized for that particular trajectory. It launched from Kourou at 5 degrees southern latitude, I think. So you basically go straight into the equatorial plane where you actually want to be for a geostationary satellite. Yeah. So that's a couple of things that worked really well in Ariane. They were relatively cheap at the time, although it was still expensive. And they had a really good run with Ariane 4. Then they replaced it with Ariane 5. And then they made, in my opinion, the mistake to replace it with another vehicle without any significant benefits. Yeah. And by that time, SpaceX was already up and running on Falcon 9. Yeah. And basically, killed the market for the rest of the team.
Yeah. You guys built, so first 3 Falcon 1s fail. I'm assuming the third one was a pretty depressing day at the company.
No, actually, the first that failed was pretty depressing.
Really, that was the most depressing.
That's the one that shocked me the most. Weirdly, I mean, it's just like the way it was. We were pretty convinced this will work, at least mostly, yeah. And seeing it fail like within 30 seconds, and then also picking up debris is not motivating. That's actually not. If all the other two went out of sight, so that's kind of like great.
Gosh, so they blew up downrange enough where you couldn't see it.
So it's like, I mean, depressing too, but it's not anywhere as depressing as actually picking up a whole rocket in pieces.
Yeah.
So that depressed me at least the most. Where was I? Okay, yeah. So the third one did a really stupid thing. We changed the engine, and the engine shutdown was different, but the stage timing was the same. So we basically rear-ended the second stage after separation because the engine just took a while to turn off.
Oh, interesting. So it was just a timing mismatch.
Yeah.
Nothing necessarily went wrong.
No, and all we changed then is like we changed the timing. Yeah, new config file.
Wow.
And so by that time we built two, almost two. One was a little bit lagging, but so we had another rocket and we launched within 6 weeks. I think the goal, Elon told us to launch within 4 weeks, and I think it took us 7 or something like that. Yeah. And there was actually, and then the other thing that was super ironic is like on all the other early rockets we had satellites. We had, I mean, not the most advanced science satellites from NASA, but we had like satellites that people worked on for like a long time.
Yeah.
The Air Force Academy had one on the first one that also was aptly named FalconSat, and that got like a mile up and then down again, and then we had some other experiments on the number 2, and then we had another satellite, I think, on number 3, which I forgot. I think it was TACSAT. But anyways, on number 4, we decided no more satellites. Right, we're done with that. We put like a big mass on there, and then that thing is to orbit.
Just random 400-pound pieces.
Still up there.
Oh, that's awesome. How do you think about risk though? When you go through all these, like every one of these failed for a different reason, right? As you went through, you're in charge of risk at the company. How do you go to Elon at that point and say like, oh, I promise you, we solved this engine timing, we solved the timing, we got configs aligned, we got this. We're not going to screw up the fourth one.
So it was different. I worked a little bit on the anomaly investigation, and being avionics, you're kind of in the center of this thing. So I was interested in the resolution avionics, so the failure investigation, and I kind of ended up managing. We started doing a list with risks at the time, so I wasn't in charge of the risk, but we just started doing a list, and so I kind of kept on working on that list too. It was, I mean, it sounds like a great thing, but it was just an Excel spreadsheet, of course.
This sounds so much more important, though.
Exactly, yeah. So we always had a list of concerns early on, and that turned into a risk list basically. And then we went more and more formal as time went on, yeah. But we didn't really have like a risk review or anything before launch.
Yeah.
Formally, we had everybody try to go around basically what can possibly go wrong after a while. After we learned that, that could be a good thing. Like, can we do anything else to make it safer and more reliably? Yeah.
Yeah.
And we kind of learned that basically the hard way, that this is a good thing to do. Because then after Falcon 1 fundamentally was too small for the market, so the market wants bigger rockets. Yeah. And we were looking at cargo to the station, which needed a Dragon basically, and then you're now in 15, 20 ton payloads with the rocket. And so that's how Falcon 9 got developed. And Falcon 9 went orbital on the first flight.
Wow.
Yeah, I was really shocked by that too.
Yeah. How long was the iteration from Falcon 1 Flight 4 to Falcon 9 Flight 1?
I'm trying to remember. I think it was 2010 when we flew Falcon 9. It was it was June, I think. Well, I need to look it up in Wikipedia, but anyways, I think it was, and then the last flight on Falcon 1 was 2008. We were successful. 2009 was the last flight. So that was a year in between. That's partly the reason why I wasn't that much involved on Falcon 9, because I finished Falcon 1.
Yeah.
And I lost a little bit like the train on that. So that's part of the reason why I didn't continue in avionics for a long time, because I just missed the next project basically.
Gotcha. Were you now? I remember these coming out a long time ago, and I don't think it was ever developed. Whatever happened to Falcon 5? Or was that what it was called?
It was just on paper.
It's no development whatever really spent on that rocket class.
Correct. I mean, the diameter between Falcon 5 and Falcon 9 is the same. It's just the number of engines is different.
Huh.
Falcon 5, I think, was inspired by Saturn 5. Yeah, you can see, we can do that, yeah. And then along the way, we fell short in performance, right? Yeah. And then we realized we need more engine thrust, and then we just fill the pattern, and now you're at 9.
Yeah.
So
Falcon 9 is almost 15 years ago to the day, June 4th, 2010.
Yeah.
Oh, 2010. Yeah. Wow. Okay.
So you are finishing out Falcon 1 program. Falcon 9's already started. And then you transitioned over to, obviously, Falcon 9 and Crew Dragon are the only things going on at SpaceX at the time. Is this, how did your role
Falcon
shift
9
with the company?
And Cargo Dragon, not Crew Dragon.
Cargo Dragon.
Very, very different.
Okay.
Yeah, because, I mean, yes, they look the same to some extent, yeah, but Cargo Dragon attaches to the, it births. It doesn't dock, it births. Yeah. So what the difference is, you basically fly next to the station. The station grapples you with the grapple, and then moves you to the door. And the door is not the docking port; it's the berthing port. Okay. And it's also square, which allows you to get like a mid-sized piano to the station. Okay. Versus the docking port is round, and the piano has to stay outside. Yeah.
So it's bigger.
Yes, exactly. And you can actually, it's important for certain, I guess, equipment that they can get through the berthing door and not through the docking door. The docking door is more like for humans. I want to say it's like 2 feet and a little bit, 2.5 maybe. Yeah.
Okay.
Anyways, it requires a lot less from Dragon. Yeah. And the action is mostly on the station to grapple. Okay. And I was always, I mean, this is history to some extent because we don't do that anymore. Yeah, we now use the docking port for everything, and Crew Dragon and Cargo Dragons and are basically the same vehicle, just somewhat modified. But it was like the easier way to dock or berth with the station originally. Yeah, so that's why we picked that way. Yeah.
Were you working reliability on Cargo Dragon?
No, I was actually guidance and control and flight safety at the time. Okay. So I gave up on the electronic, and that's actually fair because I'm not in double E. I do a little bit. I can probably get something to run, but like I'm not a designer. I don't know the more complicated digital designs. I'm not good at that. Yeah, I'm more like a systems person actually. I can put stuff together. I can duct tape it together and zip tie it together and make it work, which is exactly what you needed for Falcon 1, right? Yeah. But for Falcon 9, you needed more. This is interesting in a way because companies change, yeah. And then SpaceX, which had a lot of universally talented people, now moved into people that were specialized. Yeah, they had their the EEs were specialized. They had different software departments for the code that runs the guidance and control and the code that runs on the radio. Yeah. And so you have suddenly you build like silos and niche and have specialized people, and communication gets harder, and it's all part of the growth on the company, right? Yeah. And my talent was actually more like on a broader thing. I know how most of the stuff works, but I'm not a specialist in that sense. Yeah. And so I moved away a little bit. I continued to work on flight safety because that was critical for Falcon 9. And we actually, I don't want to say we messed it up, but we delayed the launch by 2 weeks, something like that. Mostly because this is like work with the regulatory agencies, and you have two. You have the FAA and the range, and both the range is tough. The FAA is confused often.
What range? It was the 45th.
It was the 45th base wing at the time.
Okay.
I mean, they're still called the 45th, but they're Space Force now. Yeah.
Oh, gotcha.
Yeah, and honestly, over the years, it was really good to work with the 45th Space Wing and the range, because this is all about trust to some extent, right? You're the new person on the range, they don't trust you, and so you got to work on the trust that you actually do all the tests and that you know actually your stuff, and so over the years we gained the trust, and it became easier and easier to work with the range.
Yeah.
So there was a Falcon 9 that blew up on the launch pad, right?
That was way later, right? There was one anomaly before that, actually, talking about reliability. There was one on flight 20 or 19, depending how you count. Yeah. That had there's a COPV in the second stage, and one of them actually ripped off the anchor, the wall, and then destroyed the second stage dome, and then destroyed the whole vehicle in flight. And this was a cargo flight, CR7, or I think we call it still flight 20. The thing was, flight 19 was already given to another rocket, so it technically is 19, I believe, or something like that. Rocket numbering is difficult. So anyways, it blew up basically 140 seconds into flight, and I was actually on console. So I looked down for a second, I looked up, and I see just like glitter in the air, and go, where's the rocket? And it's just like, it takes a while to sink in, and it takes more while to say, I think we lost the rocket, and to say this loud on the comm, and it takes a while. That kicked off a pretty intensive anomaly investigation. We actually rented submarines, tried to find the debris. We found a lot of debris, but not from us.
Just a random day in the ocean.
I mean, this was the traditional path that shuttle and also Apollo took, right? Yeah. So there was some hardware. There we go. And that's not ours. Let's move on.
Could have sold some of those Falcon 1 engines to, or the F1 engine to Bezos.
I mean, actually, the first Falcon 9s re-entered the ocean. If you go there, you probably find them. Similar to like Saturn V and they're all probably within the vicinity of like where usually staging happens.
Yeah.
I mean, plus trajectory. So that was actually a pretty miserable time too. We found what it was. It was a rod end that broke. Yeah. There's more to it. I mean, wide breaks and so on and so forth, but it was fixable. And then we moved on. Along the way, we also ironically lost one of the docking ports to the station. There were two payloads on that on CR7. One was a docking port, kind of important for us actually, and then a spacesuit. It was kind of important too, and one of the last actually. And so it was really really important cargo that we lost with that flight, unfortunately. And it was also the first anomaly on Falcon 9, complete anomaly. There was an anomaly before where we lost an engine. Yeah. There was like the engines were built through a process that at the time, it's different now, but at the time it was electroplating, and it's sensitive to contamination. So the plating can actually break open. That's actually how many people build rocket engines. It's a touchy process and it takes time. Nowadays, it's been completely overtaken by 3D printing.
This was the old process where you mill out the cooling chambers and then put the wax in and then electroplate over them to get the wall, so you have the channels.
Exactly, you grow it from the outside, and if you contaminate that stuff where you grow it from, then you end up with like fractures, and then over time you crack the outer hull. And then you spray kerosene to the side, and bad things happen.
What iteration of Merlin was this at the time?
At least 1, 2, 3, I think. Number 3, something like that. So the first one was like on Falcon 1, right? And then Falcon 1 had a newer version, which is the one that we messed up the stage separation with. And then I think we had a newer version for Falcon 9. More thrust, and then there were at least 2 more major versions coming after that. So anyways, so we had this. So having the first anomaly in flight 20 showed me this is different. Totally different problem. It's like a manufacturing problem, a testing problem on along the way as you build it, and not necessarily doing something wrong. On Falcon 1, we had what I call the stupid mistakes. You did something wrong, and okay, you fix it, and you move on. But then later on, as you have a vehicle that's being produced regularly, you run into this production kind of things. And I think by that time I took over flight reliability and build reliability. It was not my intention, to be honest. Flight reliability. Why did I take that? I think my predecessor left SpaceX, and I was the next logical person in that. And then flight reliability also is a different word for mission assurance. And I always struggled with that because mission assurance, I can't quite describe what it actually does. Right? It's difficult. I mean, there's like a double second look on the design and whatever, the whole process and so, But I always wanted to do more active things, So what I also did is I did the launch chief engineering, which is actually being there when you launch it, checking the vehicle, going through everything that's not right on the vehicle, and then actually working with the operations to make sure that we don't make mistakes in the operations.
But Hans, you guys did actually something really impressive here that I think a lot of other companies have failed at. It's really easy to say, oh, we had a bad strut manufactured. Let's add a whole bunch of process and checks and just continuously escalate this till you end up with unlimited process and checks. And now the vehicle costs $500 million. How did you think about not screwing that up, but also not making the vehicle cost 10x as much to not have a mistake there?
It's a good question. So when you do something like that, you find out, oh, okay, there was this one test that we did wrong. But then obviously you don't stop there, but you go, where else on this vehicle do we do the same thing, right? And now you end up with 10 more places, and that's where you escalate the whole situation. I think we were just reasonable. I don't think there was any magic, to be honest. I think we just were reasonable. And to be fair, the reason Falcon 9 is so cheap now has nothing to do with the way we build it, but the fact that it reuses the first stage and the fairings over and over. Right? That's just fundamentally the key thing that makes Falcon 9 cheap these days. You can use the first stage 28 times so far. Maybe it's 29. I didn't pay attention yesterday.
Unlimited.
Right, exactly. I don't think it's unlimited. I think you do end up with certain fatigue issues, and engines get old and stuff like that. Turbopumps get old. So I think there's definitely some runtime issues. But anyways, I mean, even 30 times is you get you build the first stage for 1/30 of the price, right? And instead of building 150 for the year, you end up with a handful.
But that's not entirely true, because there's this spacecraft before, or rocket before, called the space shuttle. And it still became more and more expensive after every flight. So how did you, on that note, how do you hold reliability but not make it cost, Space shuttle, the last flight was $1.5 billion to refurbish.
So part of that was also the standing army and the raid, right? And then the refurbishment on space shuttle was just very elaborate. It took apart the engines, took apart these turbopumps, versus SpaceX basically just inspects key points and make sure you don't push it too hard. So I think that I try to answer that for myself. Why did the shuttle fail on that, and why did SpaceX succeed on reusability? And I think part of the reason is that Falcon 9 was not always human rated. So you could actually make changes, So there's two versions basically: the human rated one, and there's the other one, And you can make changes on the other one, and then phase it into the human rated one. After you say, okay, this is flown 5 times, we know this works. We're gonna now fly this with astronauts too, right? And the shuttle could not do that. So in all fairness, the shuttle could never risk something. I mean, they took a lot of risk. The first shuttle flight, I mean, when you read about that, it just feels like, wow, the first flight, there's 2 people on there, right? They basically have very little, chances to get out. That's pretty gutsy. I mean, kudos to NASA. to do that actually. Huh?
And they did it with stolen electronics.
Right. And so all of this was pretty gutsy. And then I think they just could not bring the nerve to continue this risk over the long time. I wouldn't.
So
either,
how did you
honestly.
guys do it? Because Falcon has flown a crewed vehicle before, right? You have flown humans on it before.
Yeah, but like I said, we just fly the tests all on Starlinks. Yeah, and if it goes wrong, then you don't make that change. And so there was more to it too, right? I mean, we knew how to make changes. We had a change process. We were very careful in putting changes into the flight line. But yeah, fundamentally, the Starlinks were basically, I don't want to say the guinea pigs, but
were you nervous when you launched the crewed vehicle though? I mean, you were flight reliability. You knew all the gremlins on every spacecraft, right?
I wasn't. So I was there in the month before. I actually was not chief engineer for that launch. I was chief engineer for the first commercial crew. I give this to a good friend, and actually Bala Mammoudi was the chief engineer for that. And he worked very much with that particular mission for a long time. So I didn't want to interfere with that, because I worked on multiple missions, and he only worked on this one. So clearly he should be the chief engineer. But I was still there, somewhat nervous because things didn't quite go as they should have been. But there's always stuff that's leaking here, leaking there.
Also, it was not 100% healthy rocket.
No launch is 100%. There's always something on launches usually. I mean, at least by the time I finish. Maybe now they're perfect. Who knows? But there's always like little things. It's always like oxygen leaks and kerosene leaks, whatever. But where was I? Oh, right, exactly. I actually found the pictures because this was also like 5 years, a couple of days ago, right? On May 30, and I took a picture of my heart rate on that, and it's 63. So I figured, okay, I guess when you launch 100 rockets, you kind of get used to it at that point, right?
Fair enough. How was so there was another big development at SpaceX in your tenure there, and that was obviously the landing of Falcon.
Correct.
Was this closer to a Falcon 1 development, or was this closer? Because you guys took a lot of risk in the early days of landing. I mean, I saw that thing come in sideways and hit the drone ship, and it was really cool to see very early on. How did you think about it?
So it was not, I think there was risk for the vehicle itself. And the biggest concern for me was that we sink the the drone ship. And like basically punch a hole in it, just because then we had to explain this to the those were rented ships basically. Right? So you have to explain it.
You didn't own the ships? You rented them?
By that time, yes.
Would love to be the insurance underwriter for that ship.
Sorry, we put a hole in it, and we did punch a hole in there, a couple, but we never punched it through.
Okay. Okay.
As far as I remember, at least. So we had Grasshopper as a program to develop this on the side. Grasshopper was just awesome. It was like a dozen people led by Sean Adiers, and they did a great job just hopping with it. And there's still other countries trying to mimic this, right? There's one company in China that just recently did that successfully, actually. But Grasshopper flew many times. I'm not totally sure how many times, but so they were basically our skunk works within SpaceX to solve the problems, how to land, and so on and so forth. Yeah. So, and then we transported that technology into the normal first stages, and it didn't quite go as well. Partly also because we tried this out in the ocean. We first tried to land on the water. That worked a couple of times, but it's undecided at the end whether this was good or bad because they tend to fall over and then they blow up underwater mostly, and then we put the barges or drone ships there, and that didn't go well the first couple of times, partly because the crosswind was too strong, or partly because the sensor didn't quite work with it, and so on and so forth. There's multiple issues that we had to solve. So I think we crash landed, I want to say a handful. Then we also blew up F9R, which was the successor of Grasshopper, now with 3 engines, and and we just got a little bit cocky on the flight profile, and that make it tilt over, and then bad things happened. But so the interesting thing was the first one that landed was actually the first flight after the Flight 20 anomaly.
Wow.
So here we are, right? We did an anomaly, which, by the way, happened on Elon's birthday, on June 28th. So not a great day at all. Right? Boss has birthday, and we blow up the first Falcon 9. And so then we trying to repair this, basically, trying to figure out what it is. And then on that next flight, we actually decide to land on land. And landing on land is sounds relatively easy, but there's some subtleties. The rocket basically flies now against the Cape.
Yeah.
Right. This is the first rocket that actually comes at the Cape and not from the Cape.
Yeah.
Yep.
Yeah. And there's a cruise ship harbor behind the Cape, so you got to make sure that it does not overstep the Cape.
Yeah.
Yeah. It's got to end on the landing side and not go any further. If it goes any further, it's going to be blown up.
Yeah.
Yeah. So there's some added risk when you land on land. And I thought it was really gutsy to do that. And then, like as always, we end up pushed against Christmas because rockets are holiday-seeking missiles, right?
Yes.
At the end of the day, right? They tend to go on Thanksgiving, and this one, the schedule was such. There was like 1 day left, and the range would have closed for the holidays, basically. Yeah. And so, of course, like the huge pressure. And then we launched it. Actually, works out great. I mean, both works. The mission itself was ORBCOMM worked great. ORBCOMM got all the satellites now in orbit, and then coming back, the first landing worked great. It looked perfect, actually, from what I recall. There was really nothing wrong with that. We couldn't wait to get out to check the booster. I know we were just pacing up and down until it was safe, and then we just drove out and checked the booster.
Yeah,
there's a lot of happy people around that booster.
Yeah,
doing the rocket dance.
Why do you think none of the other? So obviously, there's a cost to landing a rocket, right? You take a fuel hit. You have to hold more fuel on the vehicle to come back and land.
Especially when you come back to land, you're going the wrong way. You got to twist that vector around.
Yeah,
and then you got to. There's a braking burn on the entry, and then there's a landing burn.
How much of the fuel on stage one are you reserving for the landing?
I don't know that number actually.
Okay,
that sounds really terrible, but I could probably find it out. But it varies actually. Yeah. What works for you is the fact that you're pretty light. Yeah. The first stage is basically 90-something% fuel. Yeah. So you're now down to really low fuel, and that's why you can barely land on one engine. The engine is throttled, but it's still too much thrust.
Yeah, wow. I gotcha. Yeah. Well, why do you think nobody previous had tried this? It wasn't some technology advancement, as far as I'm concerned, that allowed us to do this. Why do you think Delta or Atlas or the Russians never looked at relanding?
I don't know, actually. To me, this actually, okay, you could speculate there are a couple of reasons, right? I mean, because the business model works pretty well with the reusable rockets. Why mess with that? I mean, you get paid 200 million. Why would you endanger that and then suddenly get paid only for the second stage or something? Yeah.
So you think it's just incentive alignment was off for the government?
The incentive alignment was off, obviously, and this works. I mean, they don't think commercially. They think in that case like a government contractor that works government specific things. Yeah. Another reason is if you don't need so many rockets, it's like, what do you do with your people? I heard that argument. Yeah.
Build Starship.
Oh yeah, exactly. Go to the next rocket, build more rockets, whatever. I mean, there's many things you can do. But I heard that argument before. And then I heard also it's technically not feasible. There's many people that have opinions on that. It's actually on videos, some, and they didn't age well. I mean, those videos, right? They're pretty hilarious. But they're also with this undertone of arrogance. Yeah. Oh, these guys, I mean, they're new. They're nice.
That was very much the aerospace environment I would say 2010 was pre-Falcon 9 was that. I mean, SpaceX was not looked at like it is today. Let's be honest about it. It's a very different company. What do you think about, obviously you're not at SpaceX anymore. How much of Starship program did you work on? And what do you think about, obviously it hasn't gone as well as we would have liked to see so far. What do you think we need to do on Starship?
So I worked very little on Starship, to be fair. I did a little bit on the regulatory work, which didn't go great in the beginning, and on the location. I worked on the location actually, and yeah, I personally feel the last launch should have been better. Honestly, I think I know it's a new thing or rather an old thing. The other two problems, the two flights before and flight 7 and 8, they got fixed. So, but I think they need to get beyond just fixing what failed on the last one and actually making the whole vehicle more reliable. It's a complex vehicle on the other side, and it's methane is a finicky gas. If it leaks, it blows up.
Yeah.
So it's definitely a difficult development, but I don't know. I feel like the next launch should really go well.
Yeah,
I hope so. I think we're all hoping so, right?
Yeah.
It's such a big, cool vehicle to see. Like it's almost mind numbing to see how the size of that thing when it goes.
That's true.
Hans, how do you take what you've learned over your tenure at SpaceX on all these different programs, and how do you help us at AstroForge make sure that we don't repeat the mistakes of the past, but we also, do it in a speedy way, at a cost-effective way that can make sense?
Yeah, I can. So I think there's a different. So I can definitely be paranoid. I can help you with that, and I think you have to be paranoid to some extent, right? The most mistakes we made was because somebody thought this is okay. Yeah. They thought about it briefly and then kind of thought on other things instead of just really thinking a little bit deeper on that. So I can bring that flavor, and my gut feeling is also really simplifying it. Rockets and interplanetary spacecraft are not that different, actually. So satellites in general have a little bit more. They're more benign in a way. Yeah. They don't tend to blow up if you blink for a second. Things fail, but then you find workarounds in flight often. Yeah. And I've always felt like a satellite is easier to make reliable than a rocket. I mean, yeah, I think I can stand up for that statement. Yeah. Interplanetary, however, is more difficult in a way because you go away from the Earth, and whatever problem you have, your time is running out. You have to fix it, and the odds of making contact getting less and less and less. Yeah. So there's an element here that kind of works against you. It has to work from the get-go. And then if you have a reliable attitude, reliable communication, reliable power, then you can work other problems. But there's not a lot else that can fail them. These three things have to work. Yeah. And you don't have like an omni antenna pattern where you can tumble and get the signal, right? Yeah. No, you must remain stable.
Yeah. Reliability is pretty simple from a concept. It has to work. Like how do you, especially at a company like ours, how do you make reliability like a discipline or a practice here?
So I mean, there's certain analysis you can do, and I don't really believe a lot in like a probabilistic approach on that, like trying to figure out failure rates, because the failure rates you have are typically because something went wrong or something got done wrong. Yeah, so you can't put that in an equation really, right? Electronics is really super reliable if you get everything right, and then it might actually finally when you produce like 1 million laptops, you might actually get some failure rates that you can use analytically. But that's not what we have here. We have a thing that we built together once or twice, and so the key thing for me always is testing it right. Yeah, testing it as long as hard and as creatively as you can possibly do, and then really try to find what's going wrong. That's a different mindset. It's hard to. So you're approaching now your design with the mindset of what can possibly go wrong, right? And most people are not designed for that, right? They're designed, they're proud of it, and they think this can never fail, right? And it does take a little bit of a personality change. Maybe it helps if you have another person work on that. Then what can possibly go wrong, or somebody who has more like a systems knowledge or something like that. Or just somebody who is like, I'm easily suspicious and I have a good bullshit meter. And so somebody who's a little bit suspicious, basically, right? for that. But it's not necessarily what people's personality goes the other way in many cases. Yeah.
Awesome. Well, thanks for spending time with us, Hans. I appreciate it. It's amazing how much better these are without Robin.
So much better. I guess one last question. You spent 20 years building reliability. It will probably be one of the most important space companies that's ever existed. Why'd you come hang out with us?
Good question. No. Okay. So, I think actually the satellite market did not keep up with the rocket market.
Yeah.
That's just the way it is. And I feel like it can be more audacious. It can be, more braver projects. And I think that's what you do, right? At the end of the day, that's why I thought, okay, I can dare something here. Yeah. I want to do that because if you don't dare anything on the satellite market like we did on the rocket market, the rockets need daring satellites and not just daring rockets, right? So that's part of it, obviously. And then I think you have a pretty cool company, and it's a great place to work. Right? I like it here.
Awesome. Well, thanks again for spending the time with us, Hans. I appreciate it.
Welcome.
Yeah, Hans, this was great. Thank you very much for joining us for this. And that's the end of this episode.
Cool. What episode was that, by the way?
This is 15.
We've made it 15 episodes.
Oh my God.
Awesome. Thank you, Hans.
Thank you, Hans.
Thank you.
This was awesome.
Bye.